65? So you know it's referring to that pie graph down there, right? 3, 3?
Yes.
So there's a pie graph it's referring to. Okay. So it says, use a graph to determine the truth value of each simple statement, then determine the truth value of the compound statement. Okay. All right. This is kind of long, the phrase it uses. Oh yeah, you kind of work. There's just too much going on in this problem. Okay. All right, let me put this up here in case the booklets out there. Oh yeah, that helps. All right, let's see. Use the word. There we go. Okay. All right, so first off is this. This is part of the problem here. Let's see why I want to let me. Oh, it's as bright as it could be. That's neat. All right.
It's that light above it, right?
Yeah.
Return light.
There we go. Cool. So here, let's see what it's talking about. So that's what it's referring to, that pie graph. So up here it says you got to analyze this statement to see when it's true, or if it's true. The number of communications credits needed is more than the number of math credits needed. And, okay, so that's the first simple statement, is that first part, right? And then you have a connector, the and. So just analyze this first piece. Is it true that the number of comm credits needed is more than the number of math credits needed? Well, let's see. My comm credits 9, my math credits 6. So far that's true. All right? You guys with me?
Yes.
Okay. You should be with me. Nothing major's happened yet. And the number of cultural issues credits needed is equal to the number of humanities credits needed. All right, so let's see. Cultural issues credits is 6. And humanities credits needed is 6. Okay, so far that's true also. So what do we got so far? We got a true and true. So far the whole thing looks to be true. So that side is true. If and only if, what would that be as a symbol? Biconditional, which is a double-sided arrow. I like it. It has to go both ways, right? If and only if the number of social sciences credits needed is more than the number of natural science credits needed. Okay, let's see if that's true. That's the last simple statement I have to analyze. I love some of you guys. You're like, what the hell is going on? All I am doing, they've given me this picture, right? And all I have to understand is if 9 is bigger than 6, stuff like that. So is this statement true, the first one? The number of comm credits needed is more than the number of math credits needed? Yes, it's true. And, so the only way that first whole part can be true is if both parts of that are true, right? And is only true when they're both true. So sure enough, this next part was true. So far I got true. That whole thing is true so far. If and only if. So the only way if and only if could be true is when they're the same. So the other side better be true or else the whole thing is false. So that last statement, the number of social sciences is more than natural sciences. Where to go? Social sciences is 6. Natural sciences is 6. Is the number of social sciences greater than the number of natural sciences? No. So it's true if and only if false, and that is false. I like it. So you just had to break each part down, each simple statement, which is connected by ands, if and only if, stuff like that.
You want us to make tables for those?
You don't have to make a table for this.
Yeah, that's what I was thinking. I think I was overanalyzing it.
So
So if I just write false, that's enough. We're fine with that.
you got to show me some work. Yeah. You got me?
What else
You got a
do
50-50 chance in general. You see what I'm saying? So I got to see where the hell it came from.
So instead of doing the table, we would just write the 9.
So you could do this,
9 is bigger than 6.
It was like P and Q, right? That was the common math, and the other one, I can't remember now. If and only if, the last two. You with me?
Yeah.
All right, so this is interesting. So we looked at it, we saw P was true, it wasn't it? That first part was true. The comm and the math, it was true. The statement they made was true. The Q was true. The next thing, well, I can't remember what it was about, but the next thing we looked at was true, wasn't it? And the last thing we looked at was false. They were the same, that one wasn't more than the other one. Are you guys still with me? What we just did a second ago. Did you remember that?
Yes.
All right, cool. So it wasn't like, you remember what you had for breakfast on Saturday? Just what the hell we just did. Now, just like in algebra, I can plug and chug. So what do I put in place of P? True. What do I put in place of Q? True. What do I put in place of R? False. I like it. So one thing we have to talk about still is the order of operations for logic. And it's not horrible. That goes with, I call this is an equals. It's sort of like an equal sign. It breaks it up into two pieces. And I call this one super equals. So what I mean by that is, that would be the last thing I would do in this statement. I would have to do each side of it first. That's why I call it the equals. And this is the super equals, because if there was also an arrow, this would be more important than that. So I would do this before that. So this comes first, then this, then either one of these, and then that. That's the order of importance. So basically I do that first, and then I do either one of these next, and then I do this next, and then I do that last. All right, so I like to think of these as equal signs, because what do you do with an equation? You work on each side first, right? This would be the last thing you would do. So we have to do a few more of these till we get the feel of it. So what would I do?
Isn't that really just arbitrary if you know the relationship in logic?
No, it's not arbitrary, because they are related to the relationship in logic. I don't understand.
Because if you go out of operation, you'll get in a normal math problem, you'll get the wrong answer. But
Totally.
But
And you'll do the same thing here if you go out of order.
But that's what I'm saying. If you understand the relation, if you know when it can't contradict, then
No. So for example, now this one is not going to work that way because it's just coincidental. You could do it out of order, you get the same answer, just because you get lucky. But help me out here. If you did this one out of order, what should I do last? Let me see if you guys got the point of what I just said. Which one should I do last? The super equals. I have to do that last. So the correct answer, what is true or false? Or is only false when they are both false. So what's true or false? True. And what's true if and only if false? If and only if is only true if they are both the same. Are they the same? So it's false. Now if I did it out of order, the exact same statement, if I did that first, are they the same? So that the biconditional would say it's true. And what's true or true? True. I get the wrong answer. Get the wrong answer, of course. Just like in algebra, if you do it out of order, you might get the right answer sometimes if you're lucky. And here, of course, you've got a lot more chance to be lucky because how many possible answers are there? 2. Algebra, how many possible answers are there? Infinite. Shit, so you would probably be wrong a lot more often in algebra. Here, you got a 50-50 shot if you get it wrong. 50-50. Which is why I got to see your work, right? Yes?
So that would be above it. That would be the work that we would show to show that it's false.
It's wrong. Yeah, so now we plugged in the values, right? What do we do first here?
That.
The and, right? I'm going to do this last. It's like my super equals. It breaks it up into 2 halves. So what's true and true? True. And what's this? False, because it's only true if they're both the same. So it feels like algebra. That's why you don't have to do a truth table. Why do I not have to do a truth table for that problem? Because I knew the values of each of them. A truth table is if you don't know the values, you just got to cover your ass for any possible values of truth. or false. That's what a truth table does. So it's the difference between if I said in algebra, if I said graph this, when you first learn how to graph things, you would make an XY table, wouldn't you? Because you have to get all the possible values. If I said evaluate this if x equals 3, you would just plug a freaking 3 in. You wouldn't make a table of values, would you? I like it. So if you know the values, you're not going to make a table. Because a table is supposed to cover your ass for everything. If I know what the values are, I'm not going to make a table. I'm just going to plug them in. Let's try a couple more like this, I think. And then we're going to lead our way up into the big truth tables. In fact, let's remember, what is my basic rules here? What's true about and is only what? Yeah, it's only true when both true. Or is only false when both false. I like it. Can we stop there for a second? The more you know these, the easier everything will be in chapter 3, basically, right? So if you don't want to memorize these, that's your option. You're gonna suck on the test. You're gonna suck so bad. So don't do that to yourself. Why would you do that? And is only true when both are true, or is only false when both are false. What's true about if then?
It can be true either way.
False implies true.
True when it's true.
It's only false when true implies false. Right? That's the only time you can be angry, is if you held up your end of the bargain, but I didn't. That's the only time you can call me a liar. Right? If you don't make an A, I can still give you a car if I want to. Right? I won't. Okay. And then the biconditional, if and only if, is what when what? It's only true when they're both the same. I like it. So there are other ways to say these same things. There are other ways you can say these, but that's the way I look at them. Yes.
So this is second to last one, right?
If then is only false when true implies false. Okay, I like it. So let's look at this at a very direct level, where I'm not going to make a truth table. I'm just going to analyze knowing P is true and Q is false or whatever. So we can see how this works. And then we're going to apply that same procedure in a truth table. I've just got to do it several times for all the different possible values of P and Q and maybe R. All right. So let's see how this works. Let me keep that up there for now. So if I had this statement here, let's analyze this. We've got one color today. So real quick, before we plug anything in, what's the last thing you'll do in this statement? What's the last thing you'll do? Yeah, the equals, the arrow. So look at that like an equal sign. So I got to do this side. There's not much to do on that side, and I got to do that side. There's some stuff to do on that side. So that makes it, to me, it makes it very simple to think about. And it makes sense that that's the first thing I'm going to do, because I got to know what not Q is before I can OR it with R. Don't you love that sentence? I got to know what not Q is before I can OR it with R. So what is P? What can I put in place of P? Yeah, F. And this would be, just to be totally by the book, Q is true, and R is true. So this is false implies false, or true. And if you want to, you can put parentheses in if that makes it easier, right? You can just, that's the equal sign, so it splits it up into two different sides. So what do I do next there? What's up?
I feel like the statement is not correct.
This, all right, what's up?
Because I feel like it should be true since it's or.
I haven't done the OR yet.
Okay.
Do you see that? The OR is still there, so I haven't done it yet. Does that make sense? It's sort of like 7 plus 2. I haven't added yet until I put 9. I haven't given an answer for that piece yet. I haven't done that yet. All I've done is the not true is false. That's right. So now what is false or true? True. Good. So false implies, I'm going to replace this with true. And what about that? True. Yeah, the only time this is false is if true implies false. So this is true. So you just got to know those. How many things am I comparing at once at any time? 2 things. So if you know those basic statements, and is only true when they're both true, or is only false when they're both false. If you know those statements, bam, 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 bam. This is quick. Yes?
A question. That one part where you have F, arrow F, or T. How did that one go to T? Can you re-explain?
What's the only, when I say or you, clean up the room. What's the only time it's not going to get clean?
Is when neither of them.
Neither of you. So what's the only time or is false? When both are false. Otherwise it's true. False or true, right? If I said, I have been to the moon, or I am a math teacher, that is a true statement. Right? Because of the math teacher part. I have not been to the moon. Right? Or I just walked in off the street, and I have been to the moon. I think it's probably more likely that I have not been to the moon. Is that cool? Yeah. So that's what I mean. You're only ever comparing 2 things at once. So you just got to remember those little statements, those little definitions of those things. All right, let me give you one to try, and I'll shut up for a while. You guys try this one. And let's see. Stay with me. Just to make sure everybody starts off on the right foot, let's draw parentheses in. What's the very, very last thing I'm going to do? What's the most powerful thing up there? Super equals. So that breaks this up. There's not much going on with him. There's a few things going on here. Now, inside here, what's the last thing I would do? Equals. So that means I'm going to do that. That's going to be my first stuff to do there, right? So you can draw parentheses in if they don't have them in. You can draw them in, just to keep your attention in the right place. All right, let's take a look here. What can I replace it? Q is what? Q is true, so what's not Q? False, I like it. And then in here, what do I put there? False, false, and true. I like it. So false if and only if. False implies what? What's this? Yeah, and is only true when they are both true. So and is very restrictive. And is I call it the mean bouncer. Didn't I say this last time? I don't think I focused on it though. You got to be rich, and you got to look good, and you got to drive a nice car, and I'm like, oh shit, you lost me at rich, right? Or is the nice bounce. So or is like you got to be rich, or you can have a nice car, or you can have nice clothes, or you can be a match. Oh, thank God, a match. That's my weird ass club, but oh well, I'm gonna go there. All right. So and very restrictive. Or is a lot easier for or to be true because it allows for more possibilities. And is like both things have to be true. It's the only way it could be true. So what happens here now? And that's the next thing for me to do is in these parentheses. So false. Careful. The only time that's false is if true implies false. This is, you didn't do what you said you were going to do. I can do whatever I want to.
I thought it was the opposite. When true implies false, it's false.
It's true, I see. It's the other way, yeah. So this will be false if and only if true. Is that cool? And what's up with this one? They got to be the same to be true, so this is false. I like it. Cool. So really, that's just exploring the definitions of and or. Just make sure you understand those. And trust me, I totally, I understand that right now you don't see the utility of this, yeah, and that might be part of what's going on. But again, an and I know that not everybody in here is going to want to go into computer hardware stuff, maybe, right? But it'd be nice to understand a little bit about what goes into computers. And in a computer, there's these things called AND gates and OR gates. Now it's been so long I can't remember. I think it's this way. AND gates and OR gates. It's looking weird. This is just how we demonstrate them with symbols. So you put together a little computer chip, and really all it is these wires coming in to the chip. And if both wires, like if this is an AND gate, the only way that this could output a voltage is if both of them have a voltage. Both have to be true, a voltage, for it to output a true. So if one of them has voltage and the other one doesn't, then it's not going to put out a voltage. They both have to have a voltage for it to put out. That didn't come out right. What about this one? Or, what's true about or? When's it going to put a voltage out? If at least one of them, they can both have, or at least one of them has a voltage, right? And you put a whole string of these together, and somehow you make a computer. I mean, you got to put millions of these bad boys together. It's really interesting. And we actually, at one point, I took a class where we constructed our own little microcomputer. I can't remember if I told you this. And we had to have it turn something or something. I can't remember. I had to input how many times I had to turn this little Lego or something. Very useful little machine, but it's just to learn how the hell things work.
So would the whole answer be that whole table, or not table, but
That's the answer. Doesn't this feel like this kind of problem?
yes?
I mean, what do? You do this first, and then you do this, and then you add. I mean, that's what we're doing. That's all we're doing. That's it. And the really nice thing is, it's only T and F. It's not, 0 through infinity possibilities, right? You just have to learn, just like you had to learn what times meant and what division meant. Now you're learning what and means and what or means. Those are the basic operations of logic. Okay, cool. And this is like the underpinning of philosophy. Anybody ever take any philosophy courses? I think I asked this before. And you did a little bit of... Did you ever do a little bit of this? Oh, shit. All right. I'm sorry, buddy. I didn't mean to dredge that up. You're like, thanks for making me remember that. I'm sorry. But do you remember doing any logic stuff like this? It's been a while?
I don't even remember.
All right. I'll take you out. All right. So let's do this. Let's do a full truth table together. And then I got a little handout for you to work on something on your own. So let's investigate this here. Alright, so it's just like what we were just doing, except I've got to take into account all the possible values of P and Q. So that's where I put, they could both be true, Q could be false, P could be false, or they could both be false. So it's just like making an XY table. So the beautiful thing now is that's every damn thing that could possibly happen. I'm done. XY table, you just do a few and then you connect them and say, there's an infinite number of answers. There's only 4 freaking answers, I think.
Did you just make a caricature of a math person?
I made a caricature more of my students.
Oh, okay.
Yeah, that's what I normally do.
I thought you were like making fun of math nerds. I'm like, but you
Well, I don't have to do that. We pretty much walk around and make fun of ourselves. Just watch us. So in this first table, in the first line, what's P and Q? What are they?
True.
True and true, right? So what can I put underneath here? Good, because on this whole row, P is true. So right here, this is not true, that's false. What can I put underneath Q?
True.
True, and under P is true. So what am I going to do first? The and or the if then? Beautiful, right? Because the if then is like an equal sign. I've got to do that side first. So what's false and true?
False.
False. Now, I really want you guys with me on this. You guys with me so far? Sort of? All right. Let's try to do this whole thing here. Watch. What can I put here? We're not done with this yet. Let me show you the best way to do this. Not P in this case would be false again, right? And Q is false, right? And P is true. Now what about here? Not P is true. And here, let's just go ahead and not P is true. Is that cool? Q is true and false. And P is false and false. Okay. So I just filled in all the values of P and Q. Now I've only analyzed this so far, right? So let's finish this out. What's false and false?
True.
Totally false. The most false you could be. And is only true when they are both true. So the bouncer says you got to be rich and you got to have a nice car. And I'm like, I'm in. I got neither one of those things. No, he's going to say, no, dude. No, you're really bad off. Sorry. Go away. I got to have both of them so that this guy's not getting in. That's me. What about this? True and true. True. True and false? False. So what you can really do is, when you got and, you go down, you look for TT, and then everything else is false. Everything else is false. You apply the idea of and. You look for where are they both true? There. That's the only place it's true. Everywhere else must be false. Okay. So let me ask you guys, if you had to do this problem here, how would you do that problem? Don't overthink it. It's not a trick. What do you do first? 4 plus 2 is? 6. And then you take the answer of this, and you take 7 away from it, right? So what's my point there? I take the answer of this, and I do this. What am I doing this between? I'm doing it between the answers of this and these. Just the same way we did there. You take the answer, and you keep going. So the answer to this one was here. So what is false implies true? When is the only time this guy is false?
When true implies false.
Yeah, so do I have any true implies false?
Yeah.
Yeah, there it is. True implies false, that's false. Everywhere else is true. So that's my answer right there. Make sure I know which one's your answer.
I thought the other one was your answer, the first one.
That's like 6. That's like the answer 6. That's when I did the first piece. That's the first thing I had to do. What's the last thing I have to do? The equals. So that was just me adding them together. I still had to subtract. I still had to do this part. Right? So what I want you to realize, this is different, but it's the same. It looks different, but it's the same as algebra. It really is. I just don't have all these numbers I got to use. I got these letters, T and F. Let's do one more here. Come on now. All right, let's see. What about here? Let's see. So under which symbol will my answer show up? What's the last thing I'm going to do? The double arrow. So my answer is going to show up here because that's the last thing I'm going to do. What's the first thing I'm going to do? The not. I like it. All right. So you start to see how to kind of work this out. So, and you don't have to do this. The first few times you're going to do these, I'm going to do every single damn step. I'm hoping that some of you guys realize I'm going to write what Q is underneath here. I just am. Do you have to? No, they're freaking right there. But the more you do this, the more comfortable you're going to become. You're going to realize this. So I'm going to put it right here just so I can see it all lining up in my. But they're right freaking there. True, false, true, false. That's what Q is. What I'm going to put under P? True, true, false, false. That's what P does. And what about not Q? Yeah, false, true, false, true. I like it. It's got to be the opposite of what Q is. So in this row, Q is true. Not Q is false. All right, let me stop there. How are we doing so far? Is everybody cool with what I put up there so far? If you're not, ask me, because at least 8 other people are not also. Don't feel like you're the only one. That's what I love, is when I see out there, I see people going like this, and then they're the same people that totally mess it up later. I'm like, you didn't, what? Don't lie to me, just tell me you don't understand. Okay, I'm going to assume that everybody's good then. So what's the first thing I'm going to do again? Now that I got that not done? The or. I got to do the or now. So I'm just looking at these. This is what I mean by you're only ever looking at 2 things at once. That's it. So or is only false when they're both false. So where are they both false? Oh? The third one. So I'm going to put an F there. What am I going to put everywhere else? True. That's crazy. How we doing? And then maybe just circle that, so my eyes look at the right. The worst thing, and then I cross those out sometimes because those are done. I don't need those. They combined to become these, didn't they? Does that make sense? They're like 4 plus 2 combined to become 6. The exact same way. Now what am I comparing?
Q, if, and
These 2 things. I'm going to do this to them, right? Do you start to see how this is put together and why I put so much emphasis on the and statement and the or statement? Because the more you know those, the quicker this is. So when is this true?
When they're the same.
When they're the same. Where are they the same? They're the same here?
Yeah.
And they're the same. That's it. So it's true there in the first one.